This is the second part of section 2.1. This table is a good reference, but I wouldn't recommend that you write it down. Read through it, look at each of the entries, but I wouldn't write the whole thing down. Express each of the following sets using the roster method. So this is set builder notation. We have the set of all x such that x is an element of the natural numbers. Remember, the natural numbers are the counting numbers, 1, 2, 3, 4, etc. And x is less than or equal to 100. Remember, with the roster method, we want to write out all of the numbers. It doesn't matter the order in which we put them, but we usually start with the smallest number. Smallest natural number is 1, 2, 3. Now, I do not want to write all 100 numbers, so what I'm going to do is put the ellipsis, keep on going in the same way. Now when I do this, since I do want to stop at 100, I need to indicate that. So I'm going to put 100 as the last number. For part B, the set of all x such that x is an element of the natural numbers, and 70 is less than or equal to x is less than 100. So the smallest number is 70. It's a natural number, so counting numbers. And I do want to keep on going. Now be careful here because it says x is less than 100. Less than 100 does not include 100, so the largest number would be 99. The cardinal number of a set, we use n. N of A represents the cardinal number. It is the number of distinct elements in a set. So if I have a set 1, 1, 1, there's only one element in the set. The cardinal number would be 1. So the symbol, this right here, is read N of A. Repeating elements in a set neither adds new elements nor changes its cardinality. In other words, if I repeat the number 7, you don't add more elements to the set. So find the cardinal number. Cardinal number is the quantity of elements in the set. So we've got 7, 9, 11, and 13. N of A, that's the cardinal number, is 4. There are 4 elements in that set. N of B, there's one element, it's the number 0. Cardinal number is 1. N of C is the cardinal number of the set C. Now be careful here. A lot of students take 23 and subtract 13 and think the cardinal number is 10. But if you were to actually list these out and count them up, you will see that there are actually 11 numbers in that set. Cardinal number N of C is equal to 11. Equivalent sets. A lot of students have trouble with this idea, so I want you to pay attention. Set A is equivalent to set B if set A and set B contain the same number of elements. They do not have to be the same set. As long as the cardinal number is equal, the two sets are equivalent. So, looking at this example, we have the set A is the set of all x such that x is a vowel. If we were to list them out in roster method, we have A, E, I, O, and U. We have the set B, set of all x such that x is an element of the natural numbers, and 3 is less than or equal to x is less than or equal to 7. In roster method, that's 3, 4, 5, 6, and 7. Notice the cardinal number for set A is 5. There's 5 elements. The cardinal number for set B is also 5 elements. Since this one has 5 elements and this one has 5 elements, they are equivalent. Be careful with the word equivalent. If set A and set B can be placed in a one-to-one correspondence, then A is equivalent to B. That's just another way of saying the cardinal number of A is equal to the cardinal number of B. If set A and set B cannot be placed in a one-to-one correspondence, then A is not equivalent to B if the cardinal numbers are not the same. This table shows celebrities who hosted NBC Saturday Night Live most frequently and the number of times each starred on the show. Set A is the set of the 5 most frequent hosts, right here. Set B is the set and number of times each host starred on the show, right here. Are the sets equivalent? Well, set A, it has 1, 2, 3, 4, 5 elements. So the cardinal number of set A, n of A, is equal to 5. Set B has 1, 2, we don't count this one because it's a repeat, 3, 4. So the cardinal number of set B is 4. So n of B is 4. Are these two sets equivalent? No, they have a different cardinal number. A finite set. Set A is a finite set if the cardinal number, if n of A is equal to 0. So if A is the empty set, so that means a finite set, or if n of A is equal to a natural number. An infinite set, a set whose cardinality is not 0 or a natural number. The set of natural numbers is assigned the infinite cardinal number, and there is a piece missing. Should look like that, and it's rad aleph null. So the symbol kind of looks like an X with a little 0 subscript, and we read that as aleph null. So the cardinality of an infinite set is aleph null. Equal sets. A set A is equal to set B if set A and set B contain exactly the same elements. Not just the same number of elements, but exactly the same elements, regardless of the order or possible repetition of elements. We symbolize equality of sets using the equal sign. If two sets are equal, then they must automatically be equivalent. Remember, equivalent just means they have the same number of elements. Equal sets, they have exactly the same elements. Determine whether each statement is true or false. Does this set have exactly the same elements as this set? Yes, that would be true. Even though this is in a different order, it doesn't matter, it has exactly the same elements. Is this set equal to this one? No. This has 0, this set does not. This is false. And in fact, if you look at B, they're not even equivalent. They don't have the same number of elements either. The homework for this section is 8 through 96. I want you to do every 8.